Okay. So, Lillian, where are you? Can you please keep your video on? How come you disappeared? We are going to go through the homework that we did online, and with any remaining time, I'm not sure if you all recall, we have one more outstanding question, okay, from man's impact on the environment. I will show you which worksheet that is later, but I will start on the questions that you see on the screen now. So, I have a few questions where I will require you all to take down quite a bit of notes, okay? So if you don't have the worksheet printed out, I advise you to find a spare piece of paper and copy down whatever notes you see on the screen that I'm copying. Okay, Javen, do you understand what I'm talking about? You don't have the worksheet printed, right? So I want you to copy down notes when you see them on the screen. Do you understand, Javen? Okay, question 1. Chloe, Christina, and Lillian, y'all got this question wrong. Okay, Christina, can you tell me what topic is this question on specifically?
Heat.
Very good. So I want you guys to keep it a practice or make it a practice. Whenever you see a question, try to identify what topic, okay, is being tested. So this question is heat. Very good. We are looking at specifically what concept on heat, Lillian. Heat, there are many small topics in heat, right? Conduction of heat, transfer of heat, effects of heat, expansion, contraction. So what specifically are we looking at, Lillian?
Expansion and contraction.
Very good. So expansion and contraction is one of the effects of heat. So guys, if you look at the question here, we have beakers and conical flasks, okay? And the water level in the conical flask are the same at the beginning. Okay, so this is the water level in the conical flask. Wait, what's going on? Let me have a look. Okay, so the question is not very clear. The water level is actually the water level in the straw, okay? But they just say the water level in the conical flask. So basically, what you guys have to realize is at the start of the experiment, okay, if I were to draw a straight line, the water level all started out the same, all right? And then subsequently, after 5 minutes, because I placed the conical flask in beakers with different amounts of hot water, the water level rises differently, and the highest water level is in beaker B, as you can see here. Okay, so based on this, how can we explain Brian's observations? So, Chloe, can you tell me why did the why did the water level in the straw rise in the first place? How did it rise?
The water expanded.
How did it expand? That's not a good enough answer. So before you tell me water expanded, you need to tell me what happened to the water such that it expanded.
The water gained heat from the hot water and expanded.
Okay, so let's make this a little bit more clear. The water, copy down, in the beaker gained heat from the hot water. Wait, sorry, it should be the water in the conical flask. Okay, we are talking about the water in this flask. So the water in the conical flask gain heat from the hot water in the beaker. Okay. And expanded. So when it expands, the water level will rise. So what can you tell me about the amount of heat energy in the water in beaker B? Christina, is it the most, the least, or what?
The least.
Sorry?
The least.
The least, if it's the least, how come the water can rise the most? So, Christina, is it the least or the most? Sorry, I can't hear you.
The most.
Yes, everybody, there was the most heat energy in the water in beaker B. Therefore, the water in the flask in beaker B gained the most heat, expanded the most, rise the most. Okay, so if we were going through the options, option A, Javen, is option A correct or wrong?
Correct.
Good. Okay, option B, Amelia, correct or wrong? Did the water in flask A contract? Yes or no? Amelia's statement B, correct or not correct?
Not correct.
Not correct. There is no cold water in the beaker, so it doesn't make sense that the water contracted. So in fact, for the water in the straw in flask A, nothing happened. Okay, this is the original level of water. Okay, let's look at C. Chloe, is C correct or wrong?
C is wrong.
Correct, good. How about D, Lillian?
It's wrong.
What is wrong with D? Can you read out the statement?
The water in funnels or flasks in beaker B expanded more than the water in kernel or flask in beaker C.
So that is wrong. Anyway, it's conical. Okay, conical. So is that correct or wrong? Did it expand more? Yes or no?
Yes.
Why did it? How do you know it expand more? Based on what?
The height level in the straw.
Exactly. So this statement is true. All right. So what is the correct answer? Christina.
C.
Yes. Okay. So everybody, are we clear? Lillian, can you focus? My face is in front, not to your right. All right, I'm going to move on to the next question. The next question, Amelia and Lillian, you got this question wrong, so please listen up. The diagram below shows an indoor fan that uses LED lamps to provide light needed by plants to grow. Sorry, an indoor farm that uses LED lights to provide light needed for plants to grow. In which one of the following circuits will the LED lamps give out the brightest light? So here, instead of natural sunlight, we are using light from these lamps, okay, to allow the plants to photosynthesize. So we want the circuit that will emit the brightest light. So what topic is this on, Lillian?
Electricity.
Yes, specifically, we are going to look at the connection, whether they are in series or parallel, and how it will affect the brightness of the lamps. So if we were to look at circuit A, Amelia, how are the lamps connected in circuit A? Amelia, what is the connection of the lamps in circuit A? Sorry? Is it series or parallel? Look at the arrangement.
Parallel.
Parallel, look, Amelia. Is this parallel?
No.
So what is it?
Series.
So Aiman, what's so funny, Aiman? So what arrangement is the lamps, Aiman?
Series.
Good. So let's look at how much electricity flow through each of the lamps. So let's assume that each battery, okay, has 2 units of electricity. So altogether, Javen, how many units?
1.
I said each battery has 2 units of electricity.
Oh.
So altogether, the batteries have how many units of electricity?
4.
Good. Now back to you, Amelia. If I were to connect, okay, the lamps in series, how much electricity does one lamp get? If the total amount of electricity is 4 units, each lamp will get how much electricity? Amelia, yes?
1 unit.
Very good. So 1 unit, 1 unit, 1 unit, 1 unit. Why? When I have series arrangement, I am adding up. I have to divide the total amount of electricity by the number of lamps. So each lamp only receives 1 unit of electricity. Javen and Aiman, you understand what I'm talking about? Okay, let's look at B. So when we look at setup B, Manisha. Okay, Manisha, you're fine. Lillian, what is the arrangement of the lamps?
Parallel.
Only parallel? Which one is parallel? Which one is series? Look carefully, Amelia. The ones on top, how are they arranged?
The top are arranged in series.
Good. So this is series. This is parallel. So now I want everybody to pay attention, yeah? Lillian, can you tell me how much energy does this lamp receive?
4 units.
Very good. So this lamp, if you were to look at the electrical setup, it receives the entire electric current provided by the 2 batteries, so 4 units. How about the lamps on top? Lillian, how much for 1 lamp? I need to divide 4 units amongst how many lamps? Then you go and count it. So what is, sorry?
4 divided by 3.
Yes. So for the lamps on top that are in series, each will receive 1 1/3 units of electricity. Okay, so comparing A and B, we already can look at it. Which one has brighter lights? Between A and B, Javen.
B.
Okay, so I just cross out A first, yeah? Okay, now let's look at C. I'm Christina. Can you tell me how are the light lamps connected in C? The 2 on top are what? Actually, every single one is connected in what? Christina, how is the arrangement of the lamps in C?
Parallel.
All parallel, very good. So can you tell me each lamp receives how much units of light? Each lamp receives how much units of light? You should know this by now. This is a P5 topic. Christina, come on, try. For parallel circuit, there is an individual pathway for each lamp. Right, Christina? So each lamp receives how many units of energy?